You know, we're always hearing about how fast and powerful AI is getting, but there's this huge cost hiding in plain sight that we almost never talk about. The absolutely staggering electric bill it takes to run it all.
Just to put a number on it, get this. The International Energy Agency is projecting that by 2030, data centers alone could be eating up 6% of all electricity on the entire planet. And with the AI boom, well, that number is only going in one direction.
So it really makes you wonder, what if the big race for AI isn't just about who has the smartest code, but who can actually afford to keep the lights on? And that, right there, is AI's hidden power problem. This isn't just some academic thought experiment, it's a real-world engineering and economic headache. Generative AI is gulping down not just computing power, but chunks of our global power grids, and believe me, the industry is scrambling to figure this out.
Okay, so what's the fix? You might be thinking, easy, just build a better, more efficient GPU. But it turns out that's just one tiny little piece of a much, much bigger puzzle. Let's use an analogy. Think about a car. You could have the most fuel-efficient engine in the world, right? But if you stick it in a car that has a terrible transmission, the aerodynamics of a brick, and 4 flat tires, well, you're not going anywhere efficiently. Real efficiency happens when the entire system works together perfectly. So, when you take that same whole car idea and apply it to AI, it's leading the industry to this new, holistic strategy. They're calling it the full-stack power fix.
And what this really means is, well, it's simple, but it's also kind of revolutionary. The idea is to stop treating power as a bunch of separate problems. With full-stack optimization, everybody, from the person writing the software to the engineer designing the silicon chip, is working together on efficiency right from the very beginning.
So let's actually break down what this stack looks like. At the very bottom, you've got the foundation, the chip architecture. Then, built on top of that, you have the memory and all the interconnects that shuttle data around. And way up at the top, you've got the software, the brains of the operation, telling all that hardware what to do. Every single one of these layers is a fresh chance to save power.
And look, this isn't just a theory. Industry leaders are saying it flat out. If the hardware people and the software people don't talk to each other, you will never get maximum efficiency. It turns out the biggest bottleneck isn't always the technology, it's getting the teams to collaborate.
Now here's where it gets really interesting. Where is most of this energy actually being wasted? It's probably not where you think. The single biggest power hog in the system isn't running the calculations, it's just moving the data from one place to another.
I mean, this is wild. Internal tests at Google found that just shifting data from memory to the processor can use tens of times more energy than doing the actual math itself. So the new goal isn't just about computing faster, it's about figuring out how to move data less, a lot less.
So how do you solve that? Well, engineers are getting really clever. They're using Edge AI, which basically means processing the data right where it's collected. Think on your phone, instead of sending it all the way to the cloud. Some are even developing in-pixel computing, where the camera sensor itself does the analysis. And right on the chip, they're using advanced memory, like HBM, which stacks memory chips vertically, making the trip for data super short and saving a ton of precious energy.
All of these strategies, they all point to something bigger, a fundamental shift in how we think about designing these systems. We're moving away from this old brute force approach of just building for maximum power all the time and towards something way more intelligent and adaptive. See, the traditional way was to design a chip for the absolute maximum power it could ever need. That's that tall bar on the left. But the thing is, real AI jobs are dynamic. They have peaks and valleys, and they rarely ever hit that absolute max. So all that extra headroom you designed for, it's just wasted energy.
But the payoff for being smarter about this? It's huge. By designing systems that can adjust power on the fly, turning things down or even off when they're not needed, companies are cutting energy used by 30, sometimes even 50% for certain tasks.
And savings like that? Well, they totally transform this energy problem. It stops being a challenge and starts becoming a massive opportunity. Because solving AI's power crisis isn't just about good engineering anymore. It's about creating the next multi-billion-dollar market in tech.
You're seeing the entire supply chain pivot to focus on efficiency. You've got foundries like TSMC making more power-sipping silicon. You've got companies like MediaTek designing special edge AI chips to process data locally. And then you have the big assemblers like Foxconn and Quanta putting it all together to squeeze out the best possible performance per watt. So, at the end of the day, the way we keep score is changing. The future winners won't be the companies that just sell the fastest chips. They'll be the ones who can lower the total cost of ownership. That's the full price tag for running a data center, including that giant electric bill.
And they'll do it by getting a better power usage efficiency, or PUE, which is the key report card for data center efficiency.
All of this leaves us with one last, really critical thought. We are obsessed with making AI more intelligent. But maybe, just maybe, the next great leap in AI won't be a smarter algorithm. Maybe it'll be figuring out how to get that same intelligence for a tiny fraction of the power. It really forces us to ask, are we just building a future that's intelligent? Or are we building one that's also intelligent enough to be sustainable?